Welcome back to the Real Number System. In this video, we're going to look at our repeating decimals and how we change a repeating decimal to a fraction. So let's get started. To write a repeating decimal in fraction form, we must eliminate the repeating part of the decimal. We use equations to do this. The trick is to multiply our equation by a power of 10 large enough that puts the entire repetend in front of the decimal. So we're going to think about the period of the repetend, and that will tell us what power of 10 to multiply both sides of our equation by. Then we subtract the original equation from our new one, and we solve to get our fraction. Here's how this works. In example 3, we're going to convert in part A 0.5 repeating to fraction form. So I let x be 0.5555555 and so on. Our period here is 1 because we only have one digit that repeats. This tells me I multiply both sides of my equation by 10. So on the left side, that gives me 10x. On the right side, when I multiply by 10, this moves my decimal place one place to the right. So I have 5.55555. Notice that I have one set of the repetend. The repetend is 5 in front of my decimal place now. I want to get rid of the decimal place on the right side, so I subtract x from both sides. Now x is the same thing as 0.55555, so I can subtract 0.55555 from the right side. On the right side, those decimal places cancel out and we get 5. Divide both sides by 9 and our answer here is 5/9. Let's look at another one. In part B, we have 0.18 repeating. So I'll let x equal 0.18181818 and so on. The period here is 2 because I have two digits that repeat. Now I multiply both sides of the equation by 10 squared or by 100. On the left side we get 100x, and on the right side when I multiply by 100, that moves my decimal place two places to the right. And notice that I have one set of the repetend in front of the decimal place. I want to get rid of the decimal, so I subtract x from both sides. On the right side, since x is 0.181818, that's what I subtract. On the left side, we get 99. And notice on the right side that our decimal places now cancel out, and that leaves us with 18. Divide both sides by 99, and we get 18/99. Always simplify your fraction. 9 goes into 18 2 times, and into 99 11 times. And so our answer is 2/11. Let's look at another one. Suppose we have 0.317 repeating, and we want to change this to fraction form. I let x equal 0.317317317 and so on. The period here is 3 because we have three digits that repeat. This tells me that I multiply both sides of the equation by 10 to the third or 1,000. On the left side we get 1,000x, and on the right side when I multiply by 1,000, that moves my decimal place three places to the right. So notice now that one set of the repetend is now in front of our decimal place. I want to get rid of the decimal places, so we subtract x from both sides. Since x is 0.317317317, that's what I use on the right side because it's the same thing as x. On the left side, we get 999x. On the right side, the decimal places cancel out, and that leaves us with 317. Divide both sides by 999, and we get 317/999. Now, so far, everything to the right of the decimal place has been part of the repetend. But what happens if we have digits that are not part of the repetend? Look at part D. we have 2.345, and only the 45 is repeating this time. I'm going to let x be 2.3454545 and so on. Now the first thing I want to think about is I want just the repeating decimal behind the decimal place. To do that, I multiply both sides of the equation by 10. On the left side, that gives me 10x. And when I multiply by 10 on the right side, that moves my decimal place one place to the right. And so now only the repeating part of the decimal, only that repetan, is to the right of the decimal place. The period here is 2. So I multiply both sides of my equation by 10 squared, or by 100. 10x times 100 gives me 1000x. On the right side, when I multiply by 100, that moves my decimal place 2 places to the right, and so we get 2,345.454545 and so on. My goal when I'm subtracting equations is to make the decimal place go away. If I try to subtract x from both sides, I'm still going to have a decimal place. But if I subtract 10x from both sides, the decimal place goes away. 10x is the same thing as 23.454545 and so on. On the left side, we get 990. And on the right side, when I subtract, the decimal places go away, and I'm left with 2,322. Divide both sides by 990. And don't forget to simplify your fraction. 9 will go into both the numerator and the denominator. I use my scratch paper, and 9 divides into 2,322 258 times. 9 divides into 990 110 times. This fraction is still not simplified because 2 will go into both the numerator and the denominator. 258 divided by 2 is 129, and 110 divided by 2 is 55. This fraction is simplified, and so my final answer is 129 over 55. So if the digits behind the decimal are not part of the repetan, we have to create 2 new equations like we just saw in Part D. We still need one equation that has the repetan in front of the decimal, and we have to adjust the other equation so the repetan starts immediately after the decimal. We saw that in this last example. Now here's a surprising result. Let's suppose we want to convert 0.9 repeating to fraction form. So I let x equal 0.9999999. Our period here is 1. This tells me to multiply both sides of my equation by 10. That gives us 10x on the left side. When I multiply the right side by 10, my decimal place moves one place to the right. So I have 9.99999. Subtract x from both sides. On the left side, we have 9x, and on the right side, when I subtract x, I'm subtracting that 0.9999999, and the decimal places go away and leave us with 9. Divide both sides by 9, and 9 over 9 is 1. Not quite what I would have expected. Now, here's another way to look at this. I can rewrite 1 as 1/3 plus 2/3. If I think about 1/3 as a repeating decimal, I divide 3 into 1, and you'll notice that 1/3 as a repeating decimal is 0.33333333. Now if I think about 2/3 as a decimal, I divide 3 into 2, and I get 0.6666666. Well, when I add the right side together, 0.33333 plus 0.66666, that gives me 0.99999. Again, not quite what I would have expected. Here's another way to look at it. Think about 1/9. Divide 9 into 1, and you'll notice that 1/9 is 0.1 repeating. 2/9 divide 9 into 2 is 0.2 repeating. 3/9 is the same thing as 1/3, which we just saw as 0.3 repeating. Notice the pattern here. So 4/9 would be 0.4 repeating, 5/9 would be 0.5 repeating, and so on until I get to 9/9, which would be 0.9 repeating. And 9/9 is the same thing as 1. One last topic in section 7.3 is ordering repeating decimals. To put our decimals in order, we compare like place values. Tenths to tenths, hundreds to hundreds. Line up your decimals, then write out enough repetitions of the pattern so you can see where the place values differ. Let's compare 1.3478 repeating to 1.347821 repeating. Let's start with 1.3478. So this would be 1.3478, 3478, 3478, and so on. Then 1.347821 repeating would be 1.347821, 347821, and so on. I have enough decimal places I can compare. We start with the ones place, it's the same. The tenths place is the same. The hundreds place is the same. The thousands place is the same. The 10,000s place has an 8 in it, and then I get to the 100,000s place. 2 is smaller than the 3. That tells me that 1.347821 repeating is the smaller number.